congruencies, there's not, I mean, it's just congruency. It's not so much of a giant definition. We've already been talking about that for quite a while. What we're going to look at is how do you set it up? How do you talk about what's called a congruency statement via two figures? And how can you set up and solve an algebra problem via a congruency statement? Okay, so it's a lot of just basically follow the lettering. Okay. So when we talked about this a long time ago, we first introduced, the term congruency. We talked about that symbol. And congruent meant that they had equal measure. Remember that? So if we said segments were congruent, not only they were equal measure, it was like the next fancier way of saying it. We would call them congruent. So congruency means they are equal measure. Whether it's a segment length, an angle measure, or anything, it's equal in measurement. Now, when we talk about what are called congruent figures, two figures, let me write this out. Two things, I don't even want to call it, I could say or more. Two things are congruent. Do you remember what this stood for? Very good. If and only if. Two figures or more. Okay. So a lot of times you can have three, you can have four. It doesn't quite matter. For the most part, for us, we're usually talking about two things. So two things are congruent if and only if all corresponding parts are congruent. And the way that I like to start talking about this is to start talking about it in terms of lettering before I even look at a diagram. Because I always thought that it was important to understand how the letters work. Because when you have letters tell you the direction that you're moving around an object, from A to B, B to C, C to D, whatever, however it works itself through, versus looking at the diagram trying to figure it out on your own. So I always like to start out with a very simple idea. And I'm going to use triangles for our first example. I'm going to say that I have triangle ABC, and I'm going to say that it's congruent to triangle XYZ. Is everybody okay with me saying triangle by just putting the symbol of a triangle? Yeah. Okay. We do that a lot. We'll say triangle, we'll say angle, we'll use the angle symbol, sometimes we'll just use segments, and so on. Now, what I mean by what's called this idea of correspondence is I'm talking about the order in which the lettering is written. What's the first letter for triangle ABC? A. What's the first letter of triangle XYZ? X. That means that the A and X have to match up. Does that make sense? Now, how many angles do triangles have? 3 of them. So if I draw out a triangle, I say A, B, C. The vertices are how you label triangles. We all knew that. We all know that no matter what object you have, usually you label it via the vertices, where all the angles are at. You've got a polygon. It's 5 sides, A, B, C, D, and E. Those are your vertices, and so on. So I would draw the other triangle, X, Y, Z. That means that there's a direct correspondence, which means they agree with one another, they match, between angles A and angle X, because those are the first letters. So that tells me that these two match up. And is it okay if I say just angle A or angle X for something like this? Because there's only one angle A. Now, I couldn't say angle A if there was like another segment going through here. You remember that, right? The same rules apply. Now, for starters, we're just going to worry about that. So, how do you mark a diagram to show that two angles are the same? Exactly. Let's put that little tick mark through it, a little hook. A and X have to match. What are your next sets of letters? I'm like, I thought you wore your glasses today. So those two have to match because they're the second letters. And then last but not least, the third match. Now also, if you look at in terms of triangles, you have the three angles, but what else do you have? We have three angles in a triangle, but what else do you have? How much? Correct. That's yes, and that's not going to be disputed, but if I'm talking about angles, what else do I have that make up the triangles? Side lengths. Side lengths, very good. Wow, you are on top of it today. You have side lengths. Now, if you look at the way the side lengths match up, look at the lettering again. A, B, those are the first two letters, right? What do they match up with the other side? X, Y. Now, notice in the diagram, since we've already marked our diagram via our angles, see if I want to put the single tick mark for a segment here. See how it's between 1 and 2? Notice what happens here. It's the same marking, isn't it? Go to the next one. BC, 2 tick marks, 3 tick marks. YZ, 2 tick marks, 3 tick marks. Those are the same. First and last. AC, first and last. X1, or excuse me. Apparently you wanted to get out of here. Okay. What's happening here is that you're able to write out what's called a congruency statement from a given setup. So this basically tells me that triangle ABC is congruent to triangle XYZ because every piece that they have matches. So you have you have 3 angles and 3 sides that match up to each other. Angle A is congruent to angle X. Angle C congruent to Z. Side BC is the same as side BC, and what are the same? YZ. And it's a matter of using the tick marks to match for the what we call the corresponding parts to be congruent to each other. Right? That's how this works. So if I start there and start thinking about it, just even in terms of algebra and whatnot, if this is 6 and this is 2x, how do you solve for x then? Yeah, you have to set them equal to each other because of the congruency statement. And you're right, Josh, that would mean that x would equal 3. It's a real quick thing, and that's how all this stuff starts to play itself out. All right? Let's try another one. Oh, that's the same thing I just did. Here I have a statement. Do I have a picture? How many sides do these things have? 4. It doesn't say it has to be a square. Does it say it has to be a rectangle? The angle. It's just got to have 4 sides. It's a 4-sided polygon. Okay. Now, if I'm looking at just at the lettering here, I have something H, I, J, K, and L, M, N, and O. So if I want to talk about the angles, how many angles are there? Yeah, you're right. There's a total of 8 angles, but there's 4 on each side, right? So if you start thinking about it, you have 4 angles that can match up. Yeah, it's what are all the corresponding parts. So that means you'll have 4 angles, and then if you have 4 angles, you're also going to have 4 side lengths. See, you're Mr. Side Length today. All right. So angle H has to match with what? L. I just go through the list. It's just a matter of following the lettering. First letter, second, so on and so on. as you walk through your lettering, that's how you're able to find out the correspondence. I don't need a diagram to do that. I can sit there and say, well, IJ has to be congruent to what two letters? MN, very good. Everybody see why that happens? Second, third, second, third. Okay. What if I say, KH? What would have to match up? OL. Last letter, first letter. That's the idea of being able to work with what's called a congruency statement. You're looking at the lettering to find the matches. All right? Usually isn't so bad. To be honest with you, usually isn't so bad. Which allows you then to do this. Oops. Let me put this on the same side here. Take a picture.